This is kind of picking up from where we left off the other day. I'm going to be sending data from a microcontroller through p5js up to Adafruit IO. Now, normally you would use a microcontroller like one of these four that I've got here. Each of these are microcontrollers that have a Wi-Fi chip embedded on them. Um, and so these would be used to connect directly to a web service to send data. Since the microcontrollers that we're using don't have native internet connectivity, um, I'm not going to talk about these. I'm just sort of pointing them out. Maybe I'll do a video about them later on this week, but it's more of an FYI. So what I'm going to be doing is I'm going to be sending video from this. It's called an Arduino 101. It's really similar to an Uno. It also has like some sensors and some Bluetooth connectivity. I'm not using any of that. I'm just speaking serially to send data from this potentiometer into this sketch. You can see this circle changing. You can see the value down here changing. And then you can also see up on Adafruit IO that this is all getting sent up to the web right now. So I'm going to walk you through this. It's the process on the P5 side is really similar to what we saw in the previous video with sending information, to the service. I'm just going to like kind of quickly go through it. It's kind of a combination of the serial communication things that we did earlier, and then what the previous video is about. So here you can see this is my sketch. I've got, just reading the input on pin A0, and then I'm printing that out to the serial monitor, and then I'm, just storing it into this variable, dividing it by 4 because I'm only interested in values between 0 and 255. And then I'm just sending it out, through the serial monitor, right? Adafruit IO limits the rate at which we can send up to their servers, so I'm only going to update this once every 2 seconds. There's no need to do it anymore for most of the types of things that you'll be using this for. So this is it. It's really simple and straightforward. Uh, on the processing side, I've got my sketch here, and you'll see that I've got a variable to hold the serial object, something to hold the most recent bit of data from the microcontroller, a variable right here that holds the previous data from the microcontroller, so I can do this and compare the two, and that way I'll only send information up if there's been a change. And then this is the URL that I'm posting to. So I create Canvas, I create a new instance of the serial library called serial. I've got something right here that determines what happens when the serial port first opens. And then this is what to do when we get data. And so it's inside of this is where I'm actually going to send information up to the service. So right here, I've got, this is actually what's happening whenever I get data. I'm saying function that this whenever I receive data from the microcontroller in the serial port. I read the current string and I save that into a variable. I trim off any white space. And as long as there's something in there, as long as there's an actual value in there, then we'll carry on. If there's nothing in there, if I wound up sending by accident like an empty value, then we would just escape out of this and wait until we got something viable. So here I'm saving this new data into this global variable called latest data. This is the one that I'm using to draw the size of the circle over here, and then also to update the value down in the corner. And here I'm doing, if the current data is different from the previous data, then we're going to send stuff, right? If it's the same, then we don't need to bother sending anything. There's been no update. This is how it's working in this particular instance. You may have a different use case, but just for making sure that I'm not overloading the service, this is a nice handy utility to have in here. So the last thing I'm doing right here is I'm storing the current data as previous data. So next time through the loop, I've got the current value and I can compare it against the previous one. This right here is what gets called if there's new data to send. So we pass in this, this the argument right here. And this right here is the variable that has key value pairs that we're going to post. So value is paired with the value being the key, and the value that actually gets sent is the passed on down through here. We've got this send shit function, and then we send in the latest data, which in here is referred to as the shit to send. Here is the my key to post things. Yours is going to be different. Everybody's is going to be different, so don't necessarily rely on what this says inside of here. And then the HTTP post function, this sends a post message to our URL, which is defined right here. And it sends this information along with it as JSON. And then when we send a post message, the server returns something to us. And so this anonymous function right here just prints out the return down here. And so we can see this is actually what gets returned when we send something. It reports back the value, the feed ID, the feed key, when it was created. So it's just some good sort of general purpose like diagnostic information. We aren't doing anything with it, but it's nice to have. And then here inside of the draw loop, I'm just like, drawing an ellipse depending on the size of the where the pot is. And then I'm also printing it out down in the corner here. And so it's a pretty straightforward thing. And then inside of the my feed here, you can see this is over time. This is the last couple hours of my feed, and it's just printing everything out. So you can see if I just sort of hang out here for a little bit, it'll just wait there. So it's 145 is the 144, 145 is where this is at. And if we go to the most recent data in my feed, we'll see this is what it is right now, right? So this is how we send data up to Adafruit IO with a microcontroller. It's relatively straightforward, builds off of things we've already done. After this, we will show how to pull information from a feed and put it and send it to a microcontroller. And so from there, you can imagine how you might be able to connect two microcontrollers at distance this way.